Hello, dear listener, and welcome back to the Sleepy Facts Show, the place where you can drift off gently while learning something new. Tonight, we'll be exploring fascinating facts about Albert Einstein. As you settle in, feel free to let me know in the comments where in the world you're listening from. I always enjoy seeing how far these quiet conversations travel. And if you'd like to support the show, you can find those details in the description. But for now, just get comfortable and we'll ease into tonight's topic. Albert Einstein was born on March 14th, 1879, in the city of Ulm in the Kingdom of Württemberg, then part of the German Empire. Europe at the time was industrializing rapidly, and scientific discoveries were reshaping how people understood the world. Though no one could have known it then, his birth would later mark the arrival of one of history's most transformative thinkers. His birthday is now celebrated globally as Pi Day. Einstein was born into a secular Jewish family. While his heritage was culturally Jewish, religion did not dominate his upbringing. This allowed him intellectual freedom from an early age, though he would later explore philosophical and spiritual questions deeply. His Jewish identity would also shape parts of his political life. His father, Hermann Einstein, was an engineer and entrepreneur who worked in the electrical industry. Hermann's business ventures struggled at times, exposing young Albert to both innovation and financial uncertainty. Growing up around electrical equipment may have subtly influenced Einstein's fascination with invisible forces like magnetism and light. Pauline Koch Einstein, his mother, was musically talented and an accomplished pianist. She encouraged Albert to study violin, an instrument he would continue playing throughout his life. Music became more than a hobby for Einstein. It was a mental refuge and a way to think through problems. Einstein had one sibling, a younger sister named Maya. The two shared a close bond throughout much of their lives. Maya would later join him in the United States after fleeing Europe during World War II. Shortly after his birth, Einstein's family moved to Munich. There, his father and uncle started an electrical engineering company. The move placed Einstein in a growing industrial city, exposing him to modern scientific and technological developments. As a child, Einstein spoke later than most children, which caused concern within his family. Some biographers suggest he quietly rehearsed sentences before speaking them aloud. Though often exaggerated in popular lore, this early delay contributed to myths about his childhood development. Despite being Jewish, Einstein attended a Catholic elementary school. Religious instruction was part of the curriculum, and for a brief time, he was deeply religious. However, by adolescence, he began questioning religious doctrines and gravitated toward scientific reasoning instead. Einstein demonstrated a strong aptitude for mathematics at a young age. By his early teens, he had taught himself algebra and geometry beyond his school level. He reportedly called geometry his sacred little book. At age 5, Einstein's father showed him a pocket compass. Watching the needle move mysteriously in response to unseen magnetic forces left a profound impression on him. This moment sparked his lifelong fascination with invisible forces shaping reality. Einstein disliked the strict discipline of German schools. He felt stifled by rote memorization and authoritarian teaching styles. This experience influenced his later advocacy for creativity and independent thinking in education. At 15, Einstein left school in Germany without completing his diploma. His family had moved to Italy, and he joined them. He later renounced his German citizenship to avoid military service. Einstein enrolled at the Swiss Federal Polytechnic in Zurich. Though brilliant in physics and mathematics, he sometimes skipped other classes. He preferred self-directed study over formal instruction. Einstein initially failed the general portion of the Polytechnic entrance exam. However, his exceptional math and physics scores impressed administrators. After a year of additional schooling, he was admitted. Einstein graduated in 1900 with a teaching diploma in mathematics and physics. Despite his strong academic abilities, he struggled to secure a university position. Professors sometimes found him independent and challenging. During his search for employment, he relied on temporary tutoring jobs. This period of uncertainty lasted for 2 years before he found stable employment. In 1902, Einstein began working at the Swiss Patent Office in Bern. His job was to examine patent applications for electromagnetic devices. Though modest, the position gave him financial stability. Einstein reportedly completed his patent reviews efficiently. This left him time during the day to think about theoretical physics problems. His routine work may have sharpened his ability to visualize mechanical processes clearly. While at the patent office, Einstein worked independently without university affiliation. He discussed ideas with a small circle of friends known as the Olympia Academy. These informal conversations fueled some of his greatest insights. In 1905, Einstein published 4 revolutionary papers in a single year. This period became known as his Annus Mirabilis, or Miracle Year. These papers fundamentally changed physics and launched him into international prominence. One of Einstein's 1905 papers explained the photoelectric effect, a phenomenon in which light ejects electrons from metal surfaces. At the time, light was widely believed to behave only as a wave. Einstein proposed that light could also behave as discrete packets of energy, later called photons. This idea helped lay the foundation for quantum theory. Another 1905 paper introduced the theory of special relativity. In it, Einstein proposed that the laws of physics are the same for all observers in uniform motion. He also argued that the speed of light in a vacuum is constant, regardless of the observer's motion. These ideas overturned long-held assumptions about space and time. Special relativity showed that time is not universal or absolute. Instead, time can pass at different rates depending on how fast someone is moving. This effect, known as time dilation, has been experimentally confirmed many times. It means that two observers moving differently may measure different times for the same event. Einstein's third major paper of 1905 analyzed Brownian motion, the random movement of tiny particles suspended in liquid. He demonstrated mathematically that this motion could be explained by the existence of atoms. At the time, atoms were still debated by some scientists. His work provided strong evidence that atoms were real. In his fourth 1905 paper, Einstein introduced the famous equation E equals mc squared. This equation shows that energy equals mass multiplied by the speed of light squared. It revealed that mass is a highly concentrated form of energy. Though simple in appearance, the equation has profound implications. The concept behind E equals mc squared is known as mass-energy equivalence. It means that even a small amount of mass can be converted into an enormous amount of energy. This principle later became central to nuclear power and atomic weapons. Einstein himself did not initially foresee these applications. After 1905, Einstein began gaining recognition within the scientific community. Universities that had once ignored him started offering positions. His work attracted attention for its originality and boldness. Within a few years, he transitioned from patent clerk to professor. In 1915, Einstein published his theory of general relativity. This theory expanded on special relativity by including gravity. Instead of describing gravity as a force, he described it as the curvature of space-time caused by mass and energy. It was a radically new way to understand gravity. According to general relativity, massive objects like stars and planets bend the fabric of space-time. Smaller objects then move along these curves, which we perceive as gravitational attraction. This geometric view replaced Newton's earlier concept of gravity as a force acting at a distance. The mathematics involved was extremely complex. Einstein's equations implied the existence of extremely dense objects from which light could not escape. These objects, later called black holes, were initially considered mathematical curiosities. Einstein himself was unsure whether they could truly exist in nature. Today, black holes are widely accepted and observed. General relativity predicted that gravity could bend light. During a solar eclipse in 1919, astronomers measured starlight bending around the sun. The observations matched Einstein's predictions. This event made him an international celebrity overnight. Einstein's equations also predicted gravitational waves, ripples in space-time caused by massive accelerating objects. For decades, these waves remained theoretical. In 2015, scientists directly detected gravitational waves for the first time. The discovery confirmed another major prediction of his theory. Einstein received the Nobel Prize in Physics in 1921. Interestingly, it was awarded for his explanation of the photoelectric effect rather than relativity. At the time, relativity was still controversial in some scientific circles. The Nobel Committee chose the more experimentally verified contribution. Although Einstein contributed to early quantum theory, he later grew skeptical of its interpretation. He was uncomfortable with the idea that nature was fundamentally probabilistic. He believed deeper, hidden principles might restore determinism to physics. Einstein famously remarked, "God does not play dice with the universe." By this, he meant he doubted that randomness was the ultimate explanation of physical reality. His statement sparked debates with other physicists who embraced quantum uncertainty. These debates remain historically significant. Einstein engaged in famous intellectual debates with physicist Niels Bohr. Bohr defended the emerging quantum interpretation, while Einstein raised thought experiments to challenge it. Their exchanges sharpened the foundations of modern physics. In 1935, Einstein and colleagues proposed the EPR paradox. It questioned whether quantum mechanics provided a complete description of reality. The paradox introduced the concept later known as quantum entanglement. Decades later, experiments confirmed that entanglement is real. Einstein applied general relativity to the universe as a whole. Initially, he introduced a cosmological constant to keep the universe static. When evidence later showed the universe was expanding, he reportedly called the constant his greatest blunder. Ironically, modern cosmology again uses a similar concept. After 1919, Einstein became one of the most famous scientists in the world. Newspapers covered his lectures and travels. His face and wild hair became symbols of genius. Scientific ideas rarely made someone such a public figure before him. Einstein held professorships in Zurich, Prague, Berlin, and later Princeton. His lectures attracted students and scholars from around the world. Though sometimes informal in teaching style, his intellectual influence was immense. Many leading physicists of the 20th century were shaped by his ideas. In 1903, Einstein married Mileva Maric, a fellow physics student he met in Zurich. Mileva was one of the few women studying physics at the time. Their intellectual partnership has been widely discussed, with some historians debating the extent of her contributions to his early work. Their relationship, however, became strained over time. Einstein and Mileva had 3 children, Les Searle, Hans Albert, and Edward. Les Searle was born before their marriage, and little is known about her fate. Some evidence suggests she may have died in infancy or been adopted. The uncertainty remains one of the quieter mysteries of Einstein's life. Their son, Hans Albert Einstein, later became a respected hydraulic engineer. He immigrated to the United States and had a successful academic career. Though father and son experienced tensions, they maintained contact throughout their lives. Their younger son, Edward, was highly intelligent and musically talented. As a young adult, he developed schizophrenia. He spent much of his life in psychiatric institutions in Switzerland. Einstein, who had immigrated to America, never saw him again after the early 1930s. Einstein and Mileva divorced in 1919. As part of their settlement, Einstein promised to give her any future Nobel Prize money he might receive. Later that same year, he married his cousin, Elsa Einstein. Elsa provided domestic stability during his years of rising fame. Einstein played the violin throughout his life. He often turned to music when struggling with complex problems. He particularly enjoyed Mozart and Bach. For him, music was not merely entertainment, but a companion to thought. Einstein once remarked that some of his best ideas came to him in musical form. He described thinking visually and intuitively rather than strictly through words. Music allowed him to relax his conscious mind and explore ideas more freely. It became a lifelong source of balance. Einstein became known for his informal style. He disliked wearing socks and often avoided formal attire. As his hair grew increasingly unruly, it became part of his public image. His appearance symbolized the stereotype of the absent-minded genius. Einstein enjoyed sailing small boats, especially during his time in Berlin and later in Princeton. He was not considered particularly skilled at navigating. Friends sometimes joked that he relied more on luck than technique. Nevertheless, he found the activity peaceful. Einstein was a committed pacifist during much of his early adult life. He opposed militarism and nationalism, particularly in Europe. The devastation of World War I strengthened his anti-war stance. However, the rise of Nazi Germany later complicated his views. When Adolf Hitler came to power in 1933, Einstein was visiting the United States. As a Jewish intellectual, he was immediately targeted by the Nazi regime. His property in Germany was seized, and his name appeared on lists of enemies of the state. He never returned to live in Germany. Nazi authorities publicly burned books by Einstein and other Jewish thinkers. His scientific work was denounced as Jewish physics. This propaganda campaign attempted to discredit relativity on ideological grounds. Einstein became a visible symbol of intellectual resistance. Einstein accepted a position at the Institute for Advanced Study in Princeton, New Jersey. The institute provided him freedom to pursue research without heavy teaching duties. He would remain there for the rest of his life. Princeton became his permanent home. In 1940, Einstein became a naturalized citizen of the United States. He retained his Swiss citizenship as well. Although he adapted to American life, he remained politically outspoken. He valued civil liberties deeply. Einstein spoke out against racial segregation in America. He maintained friendships with Black intellectuals and activists. He publicly criticized racism as a moral failure. His support for civil rights was ahead of many contemporaries. Einstein supported the cultural and educational development of a Jewish homeland in Palestine. His Zionism was largely humanitarian and cultural rather than strictly political. He envisioned cooperation between Jewish and Arab communities. His views were nuanced and sometimes misrepresented. In 1952, Einstein was offered the largely ceremonial position of President of Israel. The offer reflected the immense respect he commanded globally. He declined, stating he lacked the experience and temperament for political leadership. He preferred intellectual work to governance. In 1939, Einstein signed a letter to U.S. President Franklin D. Roosevelt. The letter warned that Nazi Germany might develop atomic weapons. It urged the United States to take the possibility seriously. This letter played a role in launching American nuclear research efforts. The U.S. government later established the Manhattan Project to develop atomic weapons. Although Einstein's letter contributed to the project's origin, he was not directly involved in building the bomb. He did not have security clearance. After the war, he expressed regret about nuclear weapons. Following World War II, Einstein became a vocal advocate for nuclear disarmament. He warned that humanity's survival depended on international cooperation. He supported the creation of supranational institutions to prevent war. In his later years, global peace became one of his central concerns. In 1955, shortly before his death, Einstein co-signed the Russell-Einstein Manifesto. The document warned humanity about the dangers of nuclear weapons. It urged world leaders to seek peaceful resolutions to conflict. The manifesto later inspired the Pugwash Conferences on Science and World Affairs. During his later years in Princeton, Einstein pursued a unified field theory. He hoped to combine gravity and electromagnetism into a single mathematical framework. While he devoted decades to the effort, he never achieved a complete solution. Even so, the search for unification continues in modern physics. Einstein often worked alone, especially in his later years. He resisted following scientific trends simply because they were popular. This independence sometimes isolated him from younger physicists focused on quantum mechanics. Yet he remained deeply respected. In April 1955, Einstein suffered from an abdominal aortic aneurysm. Doctors offered surgery to prolong his life. He declined, saying it was tasteless to prolong life artificially. He chose to accept death naturally. Einstein died on April 18, 1955, at Princeton Hospital in New Jersey. He was 76 years old. Even in his final hours, he reportedly worked on calculations. His passing marked the end of one of the most influential scientific careers in history. Einstein's final words were spoken in German to a nurse who did not understand the language. As a result, they were never recorded or translated. This small detail has added a quiet layer of mystery to his death. His last thoughts remain unknown. During the autopsy, pathologist Thomas Harvey removed Einstein's brain without prior family permission. He intended to study it for signs of anatomical differences. The decision sparked ethical controversy. The brain was preserved and later divided for research. Over the decades, scientists examined Einstein's brain structure. Some studies suggested unusual features in areas associated with spatial reasoning and mathematics. However, interpretations remain debated. No simple anatomical explanation for genius has been confirmed. Einstein's body was cremated according to his wishes. His ashes were scattered in an undisclosed location. He preferred simplicity in death, avoiding grand memorials. This modest ending contrasted with his global fame. Einstein became more than a scientist. He became a symbol of intelligence itself. His wild hair, thoughtful gaze, and informal clothing became instantly recognizable worldwide. Posters, cartoons, and textbooks often use his image to represent genius. Few scientists have achieved such cultural visibility. In 1999, Time magazine named Einstein Person of the Century. The honor reflected the enormous impact of relativity and quantum theory on modern life. His ideas reshaped technology, cosmology, and philosophy. The 20th century's scientific revolution is inseparable from his work. Though abstract in origin, Einstein's theories underpin many technologies. GPS satellites must account for relativistic time dilation to function accurately. Nuclear energy relies on mass-energy equivalence. Even semiconductor physics draws from quantum principles he helped establish. Einstein met Charlie Chaplin in 1931 at a film premiere. Chaplin reportedly remarked, "They applaud me because they understand me. They applaud you because no one understands you." The comment humorously captured Einstein's mystique. Their meetings symbolized the intersection of science and popular culture. Einstein corresponded with Sigmund Freud about war and human aggression. Their exchange explored whether violence could be eliminated from society. The letters were later published under the title "Why War?" This dialogue showed Einstein's philosophical depth beyond physics. Einstein described his thinking process largely visual and intuitive. He relied heavily on mental imagery rather than formal equations at first. Only later would he translate ideas into mathematics. This method distinguished him from many peers. Einstein often emphasized creativity over rote learning. His quote, "Imagination is more important than knowledge," reflects this belief. He argued that curiosity drives discovery. For him, questioning assumptions was essential to progress. Einstein admired the philosophy of Baruch Spinoza. He described his own spiritual outlook as belief in Spinoza's God, meaning a reverence for the harmony of natural laws rather than a personal deity. This view blended science and awe without traditional religious doctrine. During his time in the United States, Einstein was monitored by the FBI. His outspoken political views drew suspicion during the Red Scare era. A large file was kept on him. Despite this, he continued speaking publicly on civil liberties. The chemical element Einsteinium, atomic number 99, was named in his honor. It was first identified in the debris of a hydrogen bomb test in 1952. The naming reflected his immense scientific influence. Even the periodic table bears his legacy. Einstein's life story, from patent clerk to global icon, continues to inspire students worldwide. His curiosity, independence, and willingness to challenge assumptions remain central to his legacy. More than equations, it was his way of thinking that transformed science. His name endures as shorthand for intellectual wonder. Einstein was not known for memorizing trivial information. He once remarked that he did not need to remember facts that could easily be looked up. Instead, he preferred to devote his mental energy to understanding principles. This habit reinforced his reputation as a thinker rather than a walking encyclopedia. Einstein once reflected that he had no special talents, only passionate curiosity. He believed sustained curiosity was more important than raw intelligence. More than half a century after his death, Einstein remains one of the most recognized figures in history. His face symbolizes curiosity, intellect, and imagination. Beyond equations and theories, his legacy lies in reshaping humanity's understanding of the universe. Few individuals have altered the course of science so profoundly. That brings us to the end of tonight's episode. If you'd like to hear more calm explorations like this, you can follow or subscribe wherever you're listening. And And a quiet thank you to the supporters who help make this show possible. If you'd like to support the show as well, you can join them through the Patreon link in the description. Until next time, sleep well.